Assalamualaikum and hello everyone. We are from Group C. We want to present our assignment for ordinary differential equation. Now, I would like to introduce our group members. Our leader is Lam Hui Qi, and first member is myself, Aina. Second member is Irfan, and third member is Zahid. Now, I would like to introduce our group project. First ODE is a differential equation where the highest derivative appearing is the first derivative, which is dy over dx or y prime. While second ODE is a differential equation where the highest derivative is the second derivative, which is d square y over dx square or y double prime. Both of these is type of equation are used to model various phenomena in mathematics, physics, and other fields. First, a d is refers to dy over dx is equal to f x y, where y is a function of x and f x y is either function involving x and y. Second ODE, non-homogeneous ODE, is a differential equation involving a function and its first and second derivative, where the right-hand side is a non-zero function. The general form is y double prime plus pxy prime plus x plus qxy is equal to fx, where px, qx, and fx are functions of x. This project is to develop skill in finding analytical or numerical solution to first and second order ODE. Second, this project is to recognize and classify different types of ODEs, including linear, nonlinear, homogeneous, and non-homogeneous equation. Lastly, this project is to give lesson to students on how to use initial or boundary condition to determine specific solution to ODEs.
Given in the question 1a is 2 sin dy dx equal to y cos 2x with an initial condition of y pi over 4 equals to 2. First, to make it simpler, eliminate sin 2x by dividing both sides with sin 2x. Then you will get the new equation where dy dx is equal to y cos 2x and sin 2x. Solve the division and the new equation will be d over dx is equal to y cotangent 2x. Then bring y to the other side while x to the other side, and it will become y over 1 dy and equals to cotangent dx and 2x. Integrate both sides. After integrating both sides, we will get an equation containing natural log. Use the exponent rule to remove this natural log. Turn the equation on both sides into power of the exponent. Solve the exponent equation and we will get y is equal to a square root sine 2x. This is our general solution. Insert the initial condition given where x is equal to pi over 4 and y is equal to 2 into the general solution above. And lastly, our particular solution will be y is equal to 2 times square root sine 2x. For question 1b, we are tasked to do the same thing as in question 1a, except this time we are using linear ODE method. First, change the equation in the question into standard form linear ODE. Then find the integrating factor, multiply the integrating factor, which is x to the power of 4, into the linear ODE equation. Now integrate both sides. Next step, move y into one side to form the general solution. Insert the initial condition where y is equal to 1 and x is equal to 1 into the general solution to get the particular solution. For question 1c, we are given 2y minus 2x dy, 2y minus x dy dx is equal to y. To prove it is an exact ODE, we first move everything into one side. Then multiply the whole thing by dx and separate it into n and m equation. With both sides giving the same result of negative 1, the equation is an exact ODE. To find the general solution, first integrate m equation, then differentiate it with respect to y. Compare the new equation with the n equation to find the value of hy. Then, after getting the value of hy, replace it into the new equation with y square. This is our general solution. To find the value of v, we simply substitute the given initial condition where x equal to 2 and y equals to 3. Put it into the equation, solve it and get c, which is in this case is 3.
Hi, I'm Hui Qi. I'm going to simulate our ODE assignment by using MATLAB. For question 1a and 1b, we just need to insert the equation and the condition into the MATLAB, and using the dissolve equation, dissolve command, we can find the solution of the question. For question 1c, 1, we need to identify the m and n manually and key it into the MATLAB. MATLAB will differentiate both m and n and find is it the value is correct or is same or unsame. If the value is same, we use the is equal command to find check the equation to check the value is same or not. It will display the equation is exact. Else, it will display the equation is not exact to tell you the equation is an exact ODE equation or not. For question 1c2, the left-hand side is defined by integrate minus f, and right-hand side is defined as integrate and y. Integrate y, and this integrate x. And we will display the left-hand side and right-hand side for batch checking, and define the equation I, which is left-hand side equals to right-hand side plus c. If there is exponential x, we will sub the exponential x, exponential c to c, as exponential c is a constant, which we can replace it by the c, and we subtract the full solution to find the value of the solution of the equation. For questions 1c3, we need to find the value of c. We substitute the condition given to find the value by using the sub command, and we can get the value of c equals to 3. To better checking step by step, we can view by using the output in line, which is more clear for us.
Now I would like to explain the solution for question 2. So, first, I would like to explain the method of undetermined coefficient. This method have 3 steps. So, the first step is identifying function of yc. To identify the function of yc, we must insert the equation given into the calculator. So, first, we must change this equation given into the general form, which is y double prime plus y prime plus y is equal to fx. So we must change negative y into the left hand side, and we get y double prime plus 2y prime plus y is equal to fx. To insert this equation to the calculator, we must change the y is into m. So we get m squared plus 2m plus 1 is equal to 0. When, in, when we insert the value into the calculator, we get the value of first m and second m is equal to negative 1. So we know that the yc is equal to a exponent to the power of negative x plus b x exponent to the power of negative x. Second step is find yp. Yp we must refer to the fx. So in the equation given, fx is equal to x squared minus 1. So we can assume that yp is equal to cx squared plus ex plus e minus f. So because they have two constants, we must eliminate it. So we get the yp is equal to cx squared plus tx plus e. When we do the comparison between the yp and yc, we know that they are not equal. So we can move to the next step, which is find yp prime and yp double prime. We differentiate yp for the first time, and we get yp prime is equal to 2cx plus b. We say differentiate for the second time, we get the yp double prime is equal to 2c. So when we get the value of yp prime and yp double prime, we must insert this value into the equation given. So it will become 2c plus 2 bracket 2cx plus d bracket plus cx squared plus tx plus e is equal to x squared minus 1. So we must do the BEC to get the value of c, d, and e. So when we do the first BC x square, we get the c is equal to 1. So the second BC is x to the power of 1. We get 4c plus d is equal to 0. So we just now get the value of c is equal to 1. We insert into this equation. We get d is equal to negative 4. So the last BC is x to the power of 0. We get 2c plus 2d plus e is equal to negative 1. So from the value we get a c and d, we can insert into this equation and we get e is equal to 5. So the last step is general solution. The general solution is yx is equal to yc plus yp. So the general solution will become a exponent power of negative x plus b x exponent power of negative x plus x squared minus 4x plus 5. So the second method we are used is variation of parameter. This variation parameter have 5 steps. So the first step is identify A and Fx. To identify A, we must refer to y double prime. So when we change the equation given into the uh, general equation, we get A is equal to 1 and Fx is equal to x squared minus 1. Second step, we must find yc and let yc is equal to y1 plus y2. So this second step same with the first step of undetermined coefficient. So we get the yc is equal to a exponent to the power of negative x and b as exponent to the power of negative x. So we must separate this equation into y1 and y2, and we get y1 is equal to exponent of we get exponent to the power of negative 1, and for y2 we get x e as the power of this value for y2 we get as exponent the power of negative x. So the step 3 is find Rossgren. Rossgren is we can insert the value of y1 and y2 and the differentiate of y1 and y2 into this equation. So for the equation, sorry, into this formula. So when we insert the value into this formula, we get exponent the power of negative 2x. The first step is find u and v. So the formula for u is negative integral y2 fx divided by a Ronsgren dx plus a. So we must insert the value into this formula and we get the value of u is equal to negative x to the power of 3 plus 3x the power of 2 minus 5x plus 5. All this value in the bracket multiple with exponent the power of x and plus with a. Second, we must find the value of v. So the formula for v is integration of y1 fx divided by a Roscrane dx plus b. So this same method, we must insert all the value into this formula and we get v in the bracket. We get the value of v is equal to in the bracket x squared minus 2x plus 1 bracket exponent to the power of x plus b. And the last step is a general solution, which is y is equal to u y1 plus v y2. So we must insert all this value into the general solution. And the first step, we must multiply a to the exponent the power of negative x plus the b multiple with x exponent the power of negative x. And for the rest, we must simplify the equation. So we get y is equal to a exponent negative x. I'm sorry, we get the y is equal to a exponent to the power of negative x plus b x exponent the power of negative x plus x squared minus 4x plus 5. So from both method, we can see that even though we have a different method to solve the equation given, we still get the same solution.
If we are going to discuss our question 2 simulation, in our question 2, we define the first division and second division. At first, to keep in the value, the solution given by the question, and we can find the solution by using the dissolved equation. For question 2b, we are we changing the first division and second division to m squared and m y to 1, and ignore the right hand side. We find the possible value of n because this equation by using the solve command, and define the right hand side to fx and define the a to 1. We define the 1c by checking the value of m, whereas the might have three cases, which is a real number and not a real, it's an imagination number. For real number, it will be two cases more, which is the same value or different value. For the same value, it will become actually the same, but the second it will become the same explanation x plus the times m. And for this case, the second one will times an x inside, and else it will both times x in the explanation power. For for imagination number case, it will have the present of alpha and cos, where its explanation m and x times cos m2x. And the YC is displayed this display as A times Y plus B times Z, and here is the answer. Now we need to change into metric form, where Y, Z, and the second row will become the first division of each solution. And this is for our checking, and we calculate the value of the metric form, and here is the value finding. For u and v, we need to calculate now is u is negative integral z times fx over a times the metric value plus a, and v is actually same, but z is replaced with y, and there's no negatives in front of the equation. This is a formula given, and also we need to displace the value of u and v for our on manual calculation checking. Calculation the solution of y by using y times u plus v times z, and we simplify the answer to the solution to get the exact number as the solution as we gain.
For 3a, first sort the given equation into matrix form of y prime equals to ay. Then find the eigenvalues by adding lambda into the matrix and multiply it using the AD minus BC technique. We will get an eigenvalue where lambda 1 is equal to J2 and lambda 2 is equal to negative A2. Both of our lambda value are imaginary number. Next, to find the eigenvector, first eigenvector will be represented as V1 while the second one will be represented as V2. To find the general solution, combine the two eigenvectors into one matrix. Multiply the matrix using AD minus BC. Then input V1 and V2 into the equation of Yx equal to AV1 exponent lambda 1x plus BV2 exponent lambda 2x. To eliminate the imaginary number, use Euler formula, which is exponent plus minus imaginary number theta, which is equal to cos theta minus imaginary number sin theta. So this is the process of using Euler formula for equation A and equation B. Lastly, after using Euler formula on equation A and B, combine the components so to get a solution for the final answer.
Untuk soalan pertama iaitu mencari general solution, kita gunakan bentuk Yx sama dengan AV1 eksponen kuasa lambda 1x tambah BV2 eksponen kuasa lambda 2x. Apabila dikembangkan, kita akan dapat Y sama dengan A kurungan 11 tutup kurungan eksponen kuasa negatif 2x tambah B buka kurungan 1 negatif 2 tutup kurungan eksponen kuasa negatif 5x. Kerana nilai lambda 1 dan 2 sudah diberi, jadi kita hanya masukkan saja ke dalam persamaan. Untuk soalan kedua, saya mencari YP dengan menggunakan undetermined coefficient method. Jadi saya assume YP sama dengan kurungan CD tutup kurungan X tambah kurungan EF tutup kurungan eksponen kuasa negatif X. Kemudian saya cari YP prime dan masukkan ke dalam sistem asal. Selepas gantian dan susunan semula, saya padankan koefisien X dan eksponen kuasa negatif X. Lepas untuk koefisien X, saya dapat dua persamaan, iaitu kosong sama dengan negatif 3C tambah D tambah 1 dan 2C tolak 4D sama dengan kosong. Dari sini saya mendapat nilai yang pertama C sama dengan 2/5 dan D sama dengan 1/5. Seterusnya saya padankan yang ada eksponen kuasa negatif X. Saya dapat kosong sama dengan negatif 2E tambah F dan kosong sama dengan 2E tolak 3F tambah 1. Jadi daripada ini saya selesaikan dan dapat E sama dengan 1/4 dan F sama dengan 1/2. Jadi YP yang saya dapat adalah YP sama dengan kurungan 2/5 1/5 tutup kurungan X tambah buka kurungan 1/4 1/2 tutup kurungan eksponen kuasa negatif X. Jadi untuk soalan ketiga, general solution untuk non-homogeneous system ialah gabungan YC dan YP. Jadi Y sama dengan YC tambah YP dan saya dapat Y sama dengan A buka kurungan 1 tutup kurungan eksponen kuasa negatif 2x tambah B buka kurungan 1 negatif 2 tutup kurungan eksponen kuasa negatif 5x tambah dengan buka kurungan 2/5 1/5 tutup kurungan X tambah dengan buka kurungan 1/4 1/2 tutup kurungan eksponen kuasa negatif X. Seterusnya bagi soalan 4, untuk mencari particular solution dan diberi Y1 sama dengan kosong, Y2 sama dengan kosong. Dengan menggantikan X sama dengan kosong ke dalam penyelesaian dan menyusun semula, kita akan dapat dua persamaan linear. Dari situ kita selesaikan sistem persamaan dan dapat nilai A sama dengan negatif 1/3 dan B sama dengan 1/12. Akhirnya, kita gantikan semula nilai A dan B yang kita dapat ke dalam penyelesaian untuk mendapatkan penyelesaian lengkap bagi Y. Sekian, terima kasih.
This is our question 3 simulation lab. For question 1A, we define the Z in metric form by using lambda type in, and question 3A2, we find the value of a metric Z, and we find the value of lambda by using the equation A minus I lambda equals to 0. And this is the equation showing. Now we define the eigenvalue V1 and V2, which the by saving the metric form. And in 3A3, we define the solution by using the formula y, and also we sub in the error equation to display the value of y. And it's not value but equation of y. For question 3b, we first we define y, insert the value given, because there's not requires us to find value any value of solution. For question 3c1, we need to find the VC, whereas first VC is actually depends on the value of lambda. For this, we got three cases actually. For lambda, value is a real number. There's two cases else where lambda value is same. Our YC will become this equation, and if it's not same, it will become this equation. And if the lambda value is imagination number, it will become this equation. And for our case, it's not the same value, so this is our equation as shown as here. For question 3c2, we are required to assume the value of yp, where this is because depend on our right hand side. Firstly, for our right hand side, if it's polynomial case, it will have this equation, and its explanation case, it will have the explanation equation. For trigonometric case, which contains sine or cos, it will become this equation. We will assume it become this equation. For this, actually same. The two different if else case is the one is y term and one is y term both, as the first row and second row unknown values should be different. So we have two is our case to ensure the upper row and the lower row have different unknown. And now we need to sum the y temp and yp tempo in two lines, two rows. So I will get the yp value. For our case, it will right hand side y(f(x) is equals to is an explanation case and a straight polynomial case. After summing, it will become this equation, and we need to check it for our manual. So we display the equation, and now we calculate the first differentiation for yp, and this is for our checking as well. And now the equation is defined as the first division equals to y times yp plus the right hand side, where we can calculate the value by the different coefficient of the unknown. So to collect the different coefficient and find the unknown value, we need to rearrange the equation by left hand side minus right hand side, and we got two equations for that. So this is to collect the different coefficient of x and y, and next we collect it in terms. So the x and explanation is deleted, and also it will be in independence, and we define both of them equals to 0, where we already rearrange the equation here, and it should equals to 0 here, and we can solve the value of the unknown by using the solve, and we can get the value and we replay it to check our manual calculation. And now we can sub in the value of the unknown into our YP assumed solution and get the solution of YP. For 3C3, we are required to find the solution of y, where y equals to yc plus yp, and we just need 2. And if the yp value is equals to this, but now we have only unknown a and b. So 3C4 is given give us the condition to find the value of a and b. So we submit the condition y equals to 0 at first and continue with submit the condition y equals to 0 to solve the solution, the value of a and b, and we get the answer. And we sub in the value of a and b to our y equation and simplify it to get the most simplest solution of our question.
Okay, for the discussion, first point is group collaboration. Our group work together effectively to solve various type of ordinary differential equation ODEs. We use both manual methods and MATLAB for verification. This project helps us to improve our understanding of ODEs and develop teamwork and problem solving skill. And next point is member contribution. First member is solve and explain the separable and linear ODEs in question 1. Second member is work on the EZ question and help organize the report. And third member is solve the second order non-homogeneous ODE in question 2 using both method. And last, member 4 is solve the system of first ODE in question 3 and verify all answer using MATLAB. And what we learn from this project is from question 1, we learn how to use separation of variables, solve linear first ODE, and identify EZ equation. From question 2, we learn to solve second order non-homogeneous ODE using undetermined coefficient and variation of parameters. From question 3, we understood how to work with system of ODE using metric, eigenvalues and eigenvectors. And difficulties that we face is first verifying result for complex equation, especially in question 2 and 3 was challenging, and the variation of parameters method was time to consume and need careful interpretation and interpreting MATLAB result and matching them with manual solution require extra attention. And what we get of MATLAB is MATLAB help us verify our manual solution accurately. It allows us to plot solution curve and perform symbolic calculation easily. And when we use MATLAB, it save time and increase our confidence in the correctness of our answer.
For the conclusion, in this project, our group worked together to solve different types of ODE, linear, non-linear, homogeneous and non-homogeneous. We used both manual calculation and MATLAB simulation to verify our results. One challenge was ensuring our manual work matched the MATLAB outputs. Through this project, we gain a better understanding of first and second order ODEs and improve our problem-solving skills. These are valuable tools for applying math to real-world problems, such as in physics and engineering. That's all from our group. Thank you for watching.